opened it up, that's easy to do. The muscular layer is the myocardium. Muscle layer is myocardium. And so in your thing that you've got opened up, it's easy to see the muscle. I mean, it looks like meat. That's the muscular layer. Okay, all of this is myocardium. The endocardium is the inside lining where the blood would flow. And if I could describe it, I would say it's slick. Yeah, well, that's actually a valve, but like right in here, that's endocardium. And the blood would flow and it would flow through that valve and it would go out. So over here, oops, sorry, if you open that up, there's the endocardium there. Now, it doesn't feel super slick in these, but if you ever have an opportunity to look at a heart that's not been sitting in preservative for a long, long time, the inside is just really slick. So why do you think we want that to be so slick? Well, it's just like through there. We don't want friction. Friction means high blood pressure. It means your heart has to work harder. But we want it to be slick so the blood moves through. Okay, so then we want to look at chambers. You guys already saw the right and left atrium. Right and left ventricle are down here. So here's your right ventricle. Here's your left ventricle. Now, I told you we always want to have it to where that little fatty line goes across like this. Well, sometimes it's not real obvious and it's easy to get confused. So when you open it up, the myocardium on the left side is always a lot thicker than the myocardium on the right side. So here's my right side, and see,
Thicker on the right side?
Thicker on the left side. Here's my left side. Look at the thickness here compared to the thickness here. The muscle is thicker on the left side. Why? We'll talk about that in a minute. But there is a very important reason for it. Okay, so like when you guys open up right side, left side. Left side's almost double the thickness. So that way you always can tell if you've got it oriented correctly.
Oh, no, hold it. Like you are. Pick your arm up. All right, good. Hold the heart. I'm moving you.
Okay.
Yeah. Here. Like that. There you go. Okay.
So
you go.
Now hold it for an hour.
Yes. Because if I'm facing you,
Oh, you could put it
this
down
is my
now.
right hand, but that's
Sorry.
my left side. So you got to think about this
These
heart
videos
as
they
being
bring.
in
Oh,
the
yeah.
anatomical position you're facing you.
This is our measure.
Just like this.
So we got it this way. Okay, so like, oh yeah, I can see what's
Okay, so now we want to look at valves. The valves separate the chambers. And so we have a tricuspid and bicuspid valve. Those separate the atria from the ventricles. And so when you open your heart, you see some stuff. This is Sarah, this is what you were asking. Is this my endocardium? It was a valve. It looks white. So that's a valve right there, and it's really tough. The other one is in here, and if you spread it open, it's part of it is right there, and part of it's right there. You actually cut it in two, and here's the other little piece.
So then it would all just go through.
Right, when it's all put together. So with you guys, this is a piece of your valve. It's like a little flap of tissue. The other piece of it is right here. And there's some goopy in there. On this side, you bend that open. Here's your valve right here, and you can, if you get full, hang on. If you get, I'll get these little pointy ones.
At some point, I got to, this is all the
That's part of your valve
Okay.
right there. And this is just like a flap of tissue. It's really tough. And this is part of this valve, if you put it all back together. And there's some of the little tissue flaps. And then here's a well, you don't have much over here. You got a little place where it was attached, but most of it is right there. Okay, so we pointed out valves. Those are your tricuspid and bicuspid. You also have two semilunar valves. They're going to be kind of difficult to see with these hearts. You really have to cut into them and dig around in them. So we'll look at them. We'll look at them on the model. Okay, so here's my model. On the right side, this is my right AV valve or my tricuspid. Then over on the left side, left AV valve or bicuspid. Now these valves are kind of like little tissue flaps, and so they have anchors that hold them to the wall of the heart, and they're called tendinous cords because they're white like tendons and they're little cords. So when you saw those tissue flaps, did you see the cords, the long skinny cords coming off of them? Those are your tendinous cords. And if you trace those tendinous cords down and go to the wall of the heart, they attach to the wall of the heart, and there are muscles sticking out called papillary muscles. See how this is not real smooth, but it's sort of lumpy and bumpy? Those bumps that are sticking up are papillary muscles that are attached to those
This
cords.
stuff.
That's the what you're talking about.
Mm-hmm. Yeah, that's really nice. Those cords, you can see them really well right there. And see how these the cords attach right here, and this is kind of bumpy, kind of raised up right there. That's your papillary muscle. And you see it some more down here, because some of those cords will come on down here. And you would see it to a lesser degree in here, if you can wedge that apart and trace them down here. There's some right down in there where it's kind of bumpy.
This.
Right there's a pretty good one.
Oh, I see. It's real thick.
Yeah.
This stuff then. Yeah, it was bumpy too. No.
Okay. So we got 4 chambers. We have 4 valves. We've talked about 2 of the valves. The other 2 valves lead away from the heart ventricles and to the blood vessels. So we've got a pulmonary semilunar valve right here. It divides the right the right ventricle from the pulmonary trunk. Divides the right ventricle and pulmonary trunk. Then your aortic semilunar valve is way up in here. So you could find them in these hearts, but you'd have to do some more cutting and get pretty deep in there. The aortic semilunar valve is going to divide the left ventricle from the aorta. Okay, so then that means that this blood vessel is your pulmonary trunk, and this big blood vessel is your aorta. Now, in these hearts, it's kind of difficult to see the blood vessels, but you can probably tell the aorta because it's big.
Yeah,
it's big enough to stick your whole finger down in, and it's thick. So we saw yours. It comes out of the heart, and it makes a real sharp turn, an arch, and goes back down. Okay. The pulmonary trunk, if you dig around in that fat, you may be able to see it. You probably see where it splits. Pulmonary trunk leaves the heart, comes up here, and it splits in 2. One split for each lung. So you may be able to see some of the splits. So So we'll take a look at these, and then we'll draw in our picture. And we'll label everything that we want to know. So like, for you guys, I believe this is the aorta. And see how thick that is. It's gonna come up, like it leaves the heart here, and it's gonna turn and go down. And so we're catching it right there in the turn. That's probably one of your pulmonary. I'm guessing that that's where the pulmonary trunk splits to go to each lung. Right there. They're still pretty thick, but not like this one.
I like it.
That's a good way to do it.
So, aorta and pulmonary.
So, yeah. Aorta and maybe, I think this is your pulmonary. Right
We
there.
cut that off, didn't we? Yeah, we totally cut that off.
Okay, I'm betting.
Maybe not. Well,
It was very thorough.
we're the best. Don't
It's
tell.
hard to tell, and if you wanted to take a lot of time, you could trim all this fat away and make it really nice and smooth.
Mhm.
That takes a long time. Okay, that's probably an vena cava, because it's not real thick. See how the thickness of this is compared to this? That's probably a vein bringing blood back to the heart. But definitely aorta, and I think up here is the split from your pulmonary. Not as big, but still pretty
Yeah.
decent sized.
I was playing.
So on the models, it's a lot easier to tell your blood vessels because you don't have all that fat in your way. So this one's the pulmonary trunk, this one's the aorta. And the other two vessels that we want to look at are vessels that bring blood into the heart. One is the vena cava, and you've got a superior vena cava and an inferior vena cava. And this is what brings blood to the heart from your whole body. So the blood out of your head and your upper part of your body comes into the heart through the superior vena cava. The blood from the lower part of your body enters the heart through the inferior vena cava.
That, oh, jeez. Stuff.
And then over here on the left side, we have two pulmonary veins. But we'll draw all this in the picture, so I think it'll be a little bit easier for us to see. On your hearts, it's doubtful that you'll see the vena cava or the pulmonary veins because they probably got messed up when they took the heart out. And with that coupled with all the fat, it's pretty difficult to see. So now let's take a little break. Let's look at our heart model and let's label everything and make sure you've got some good stuff down in your notes.